To allow easy machining of all of the features that are on the side of the part, on all four sides, like these, such as these holes, the case, the I/O connectors, and these other holes that are at odd angles. What we're going to do is make this piece, which is a mounting fixture. This will be bolted onto the rotary table with these bolts. It'll be centered with a dowel pin to the center of the table, and then the CNC will be zero reference to the rotational axis of this part. That way we can rotate this around on the rotary table and work on all the sides without having to re-clamp it in the vise and re-zero it each time. This will save a lot of time re-zeroing the machine. Since the back of the camera will also need the same operations on all sides, just like the front will, I've designed this one fixture to handle both parts. So we don't have to make another fixture just for this back part. To make this fixturing block, I'll do the minimum number of operations required on the manual mill in order to bolt it down to the rotary table. So that's going to be drilling the 4 holes and facing off one of the surfaces. Then we'll bolt it down to the rotary table on the CNC and do all the other operations there. So the top of this cut is a little bit higher here, lower here, so we'll set the 0 approximately here, lock it down, then move off to the side and move it up a little bit, say, I don't know, half a millimeter or so. I think I'm actually going to take a finishing pass on that too. It's a bit rough. Set 0 in this part. We'll just, it's not that critical, so we'll just approximately touch off of one edge, 0 the DRO, and then just go to the other edge, again approximately touch off, and now what we have to do is go Y 1/2. And now the DRO is centered. The 0 is in the center of that part. I've set the quill stop to stop the quill from going down at the mark I made, the depth for the counter bore. This is just going to be 8mm above the bottom of the part. This is being done with a 5/8 inch end mill. Those shavings are getting in the way, and those are pretty sharp. Now I'm going to make a 30mm diameter plug. This will fit into the hole we're going to bore on the top of that fixture piece, and that will center itself in the pin, in the hole in the center of the rotary table. That will ensure that the fixture is aligned to the rotational axis of the table, because that will be important in how we're going to do the reference position for the mill. Okay, that's about 33.4mm right now, so we got to take it down to 30. And we need the pin to be 16mm long, so that is plenty long enough. So we're now at, call it 33.07. So we need to go about 11.4 thousandths of an inch further. Actually, sorry, half that. That's just about perfect. 30.04. Okay, right on the money. I've cut that off from the bandsaw now and chucked it back up, so now we just need to cut it to the length and chamfer the end. So we need to take off about 10 thousandths to get it down to 24mm length. Now we have to bore a hole for this pin to fit in. I'll start by boring down with a 3/4 inch end mill. That's the biggest size I have right now. And then we'll enlarge it with a boring bar. Okay, boring head is set up. Give it about a 50 thousandths pass. Getting a bit of chatter there. See if some oil helps that. See if slowing it down helps. Oh yeah, that's way better. So just going too fast there. The last operation is to drill a couple of holes to be threaded for bolts that will hold the workpiece to the fixture. And the last thing to do is tap the holes. And we'll power tap using the mill itself, just on a low speed. This is a taper tap, so you can pretty much just drive it right through. Check how the chips are clearing. It's not too bad. Yeah, I think we can just safely drive that all the way straight through. That is tighter than I would like. Might have to heat the block up to get this in. Oh, that's way easier. Yeah, I just heated it up by putting it in a sink full of hot water. To set the X and Y zeros, we'll use the coaxial indicator. This is just a device that, as it turns, gives you an indication as to how far it is, how far it's off center. So to use this, we'll just get it approximately correct in X and Y. So for Y, we'll just set it to 0. Go to the other side. We're about just about under half a turn. So we just need to move it till it's about halfway between 0 and where it was. So about, it was at 20, so it's at around 10 or so. So now that's pretty close. Now we'll do the x-axis. So that's again about 0 and about half a turn, around 22. So we'll go to 11. Now we're much closer. And we just repeat this until we get it to as accurate as we can get, or whatever accuracy we desire. So again, we'll 0 it. Now it's around 2 off. So I'll just go into step mode because we're going to be moving very small amounts now. Perhaps that's a bit too small a step. It's a bit fast. Yeah, set it to about 1. On the other side it's about 1 as well. And that is pretty much perfect there. Just get an idea of how much, what scale this dial's at. The dial is at sort of an arbitrary scale, so we'll move it by 1/1000th of an inch. So that's about 1,000, so it's about 2/1000ths or so. Now it's going to do 2 finishing passes. One to finish the walls and one to finish the floors. let's see how this fits now. Okay, that's a little bit loose in the x-axis. It's really good in the y. Looks like, what do we got? About 5 thousandths or so out. Let's see. That is pretty much spot on. 0.02 millimeters small. Camera case. Must be the camera case is big. Yeah, that's almost 0.15 millimeters. Get this right. Come on. Yeah, but almost 0.15 millimeters too big. So there's some error on the machining of the of this case. It was a little bit too big on the inside, even though earlier I checked the outside dimension is perfect. So at least there's not a problem with this. So I can probably just put some shims on each side to hold it correctly centered when actually using this. And then this, the standard clamp bar from the clamping set seems to work just fine. Oh, that's nice. Yes, that's really solidly fixtured. Rotary table's all set up now. The machine is zeroed correctly. So all we have to do now is clamp the piece in and we can start the program and finally finish off this part. It does distort it just a little bit, so I don't want to clamp it too tightly. Okay, the offset seems to be set correctly. I think I've run into another bug in the machine. When it was about to go to rapid right through that hole, that would have obviously broken the drill bit. So let's just run it again without the tool in place. This is that same drilling operation. So I'll move up so you can see the position of the spindle. So right now, yes, it went down, then up. And now it's doing the drilling operation as it should. That's very wrong. I've modified the program. Let's give that another go. Yep, that's working better. it's going to contour the area around the hole for the fan. This operation will profile the little edge around the where the power button and charging LED indicator go. Now we change it to this other angle, 22.5 degrees, and this will then we'll drill a little hole up here. Now to the next angle of 90 degrees. Now this is going to be really close. Okay, that's good. Quite a few holes to drill in this on this side, because this is the side that has all the air holes for to let air in for the fan to suck out. Definitely optimize this by having it wrap it in much closer to the surface. This is a pretty cautious program. Sorry about the focus there. operation. This one just cuts out the corners tighter using a 2mm end mill. That's it. The front of the camera is finally done. Okay, now that just looks beautiful. So it's been incredible going through the complete process of building this. All this video was shot over about 4 full days of work. Definitely a big learning experience. A lot of the time was caused by problems with the machine, problems with G-code. If I were to actually go and make another one, it would probably take a lot less time, maybe 4 or 5 hours. Definitely a slow machine. A modern machine could make this much faster. All that effort in fixturing seems to have paid off, because the alignment with all the holes on the 3D printed part is pretty much perfect. Even the oddball one out in the corner is lined up just about perfectly. Let me know if you'd like to see more of these super long, super detailed videos like this, or if you'd rather me make shorter, more cut down videos. Anyway, I hope you enjoyed this video on making the camera enclosure. Thanks for watching.